The most decisive military operations rarely begin with visible signals. There is usually no public warning, no immediate escalation indicators, and no obvious mobilization that would trigger global attention. Historical examples, from the Six-Day War to the opening phase of Operation Desert Storm, demonstrate that the initial advantage often comes from surprise combined with speed. By the time external observers recognize that something significant is happening, the most critical phase is already underway and, in many cases, irreversible. This kind of operation does not begin at the moment of execution. It begins long before that, during planning cycles that include intelligence gathering, systems mapping, vulnerability analysis, and repeated simulation. Modern militaries rely heavily on wargaming environments and digital modeling to test timing, sequencing, and expected outcomes. These simulations are not theoretical. They are data-driven and based on known system behaviors, including communication latency, radar refresh rates, and response timelines. In operational environments, informal naming conventions often exist. These names are rarely public and are not part of official documentation, but they serve as internal identifiers. They usually reflect intent rather than structure. When such a name is used consistently across units, it signals that the operation is coordinated, pre-approved, and designed for decisive execution, rather than gradual escalation or defensive posture. Operations of this type are built around time compression. Modern doctrine, particularly within frameworks like multi-domain operations, emphasizes that the first few minutes of engagement can determine the effectiveness of the entire campaign. This is because command and control systems depend on synchronization. If synchronization is disrupted early, the system may still function, but it will not function cohesively. That distinction is critical. A force that can act but cannot coordinate loses efficiency at scale. At the point of execution, command centers operate under strict procedural control. Lighting is typically minimized to enhance screen visibility. Acoustic environments are controlled to reduce distraction. Personnel operate within predefined roles, and communication follows structured protocols. There is little to no informal conversation. Every action is tied to a checklist or operational directive. This is consistent with real-world command environments observed in both military exercises and documented operations. Readiness confirmation follows a standardized format. Each unit reports status in concise, unambiguous language. There is no interpretation or elaboration. Responses are binary, ready or not ready. This reduces the risk of miscommunication and ensures that the command structure has a clear operational picture. There is always a final verification stage. Technically, this stage allows for abort or delay. In practice, once an operation reaches this point, reversal is unlikely. Strategic, logistical, and political factors have already been aligned. Execution becomes a matter of timing rather than decision-making. When execution is authorized, it begins immediately. There is no countdown in most real-world scenarios. The absence of a countdown reduces delay and prevents synchronization errors. Systems are already aligned to initiate actions within milliseconds of the command. The operation itself is multi-layered. Modern military doctrine integrates cyber operations, electronic warfare, space-based assets, and kinetic strikes into a single coordinated framework. This is often referred to as multi-domain integration. The purpose is to create simultaneous pressure across different system layers, making it difficult for the opposing side to isolate and respond effectively. The first actions typically occur in the digital domain. Cyber operations target network infrastructure, data routing systems, and communication protocols. These actions are not designed to cause immediate system failure. Instead, they introduce instability, packet loss, increased latency, intermittent disconnections. These effects are subtle, but impactful. Studies in network-dependent systems show that even minor delays can significantly affect decision cycles, especially in environments where timing is critical. In parallel, electronic warfare systems may begin signal interference. This includes jamming specific frequencies, introducing noise into communication channels, and disrupting radar signals. Again, the goal is not total blackout. It is partial degradation. A system that fails completely is immediately recognized. A system that behaves inconsistently creates uncertainty. Space-based assets are adjusted during this phase. Satellites used for reconnaissance, navigation, and communication can be repositioned within their orbital parameters. These adjustments are routine in isolation, but when coordinated with other actions, they enhance targeting accuracy and situational awareness. Timing these adjustments ensures that coverage is optimized at the exact moment it is needed. The next layer involves activation of forward and long-range assets. These include stealth aircraft, naval platforms, and missile systems designed for standoff engagement. Stealth technology reduces detection probability by minimizing radar cross-section and controlling heat and electromagnetic signatures. These systems are deployed in ways that avoid triggering early warning systems. Timing alignment is critical at this stage. Operations are synchronized so that multiple actions occur within very narrow time windows. This creates what is known as temporal saturation. Defensive systems are forced to process multiple inputs simultaneously, increasing the likelihood of delay or error. On the receiving side, initial indicators are often ambiguous. Operators may notice irregularities, slower system responses, inconsistent data feeds, or brief communication losses. These are typically treated as technical issues rather than immediate threats. Standard procedure is to run diagnostics and verify system integrity before escalating. This creates a delay in recognition. By the time anomalies are identified as coordinated interference, the operation has already advanced. Within the executing command structure, data aggregation is continuous. Targets are pre-identified based on intelligence analysis. These targets are monitored in real time, and their status is updated automatically. Systems display this information in structured formats, allowing operators to track progress without interpretation. The operational window in this scenario is 10 minutes. Short duration, high-intensity operations are consistent with doctrines that prioritize rapid dominance. The objective is to achieve maximum effect before the opposing side can organize an effective response. The focus is not on widespread destruction. Targets are selected based on their role in system coordination. These include radar installations, communication nodes, command centers, and logistical hubs. Disrupting these elements reduces the system's ability to function as a whole. At approximately 2 minutes, physical engagement begins. Precision-guided munitions are used to strike selected targets. These weapons rely on GPS, inertial navigation, or laser guidance to achieve high accuracy. The goal is to disable functionality, not necessarily to destroy infrastructure completely. On the receiving side, information flow becomes fragmented. Reports arrive at different times. Some are delayed, others are incomplete, and some are not received at all. Decision makers must act on partial information. This increases cognitive load and reduces decision accuracy. By 3 minutes, patterns begin to emerge. However, incomplete data makes it difficult to confirm these patterns. Uncertainty affects decision-making. Commanders must choose between acting quickly with limited information or waiting for confirmation and losing valuable time. At 4 minutes, the pace becomes a defining factor. Human decision-making has limits. Under high-pressure conditions with incomplete information, error rates increase. This is supported by research in cognitive psychology and human performance under stress. By 5 minutes, system strain is evident. Communications are degraded but not entirely disrupted. Coordination exists but is inefficient. Units respond, but their actions are not fully synchronized. This level of disruption significantly reduces operational effectiveness. The executing operation continues without deviation. Because planning accounted for timing and sequencing, there is no need for adjustment unless unexpected variables are introduced. This reliance on pre-planning is a defining characteristic of such operations. At 6 minutes, reinforcement actions begin. Targets that have been disrupted are engaged again to prevent recovery. This technique is consistent with suppression strategies used in modern warfare, such as suppression of enemy air defenses. Repeated disruption ensures that systems cannot stabilize. Mental fatigue becomes a significant factor. Operators dealing with continuous, incomplete information experience reduced cognitive efficiency. Decision fatigue affects both speed and accuracy. This is a well-documented phenomenon in high-stress operational environments. By 7 minutes, coordination becomes apparent. The receiving side recognizes that the events are not isolated. This changes the strategic interpretation. The situation is now understood as a coordinated operation, which increases urgency but does not immediately improve response capability. At 8 minutes, adaptation begins. Operators switch to alternative communication methods. Decision cycles are shortened. There is less reliance on full verification. This improves responsiveness, but increases the risk of error. Adaptation is effective, but requires time. At 9 minutes, decision-making accelerates. Responses are faster but less certain. The margin for error is reduced. Command structures shift from proactive control to reactive mitigation. The final minute focuses on completion. Remaining targets are engaged. Any gaps in the operational plan are addressed. The objective is to ensure that all intended effects are achieved within the defined time window. At 10 minutes, active operations stop. There is no immediate continuation. This is intentional. Short-duration operations reduce exposure and limit the opportunity for counteraction. The aftermath is defined by uncertainty. Systems remain degraded. Communication is inconsistent. Coordination must be rebuilt. Assessment begins, but full clarity is not immediately available. The primary outcome is not destruction alone. It is the alteration of operational conditions. Decision-making speed has been disrupted. Coordination structures have been weakened. The environment has been reshaped in a way that affects all subsequent actions. This is the defining characteristic of operations built on speed and synchronization. They are not designed solely to strike targets. They are designed to control how the opposing side experiences time, information, and decision-making under pressure.